sure that it records. Okay. Testability. Testability. Thing is recording happily. Okay. Ladies and gentlemen, testing is not just about finding bugs, finding defects. It serves many purposes. Okay. Identifying other quality problems. Give me an example of a quality problem that's not per se a bug, but is something that you want to deal with often. What's not a bug, but it's an issue with quality, value delivery. Yeah. Oh well, actually, you're speaking out, and that's great. But I'll take a suggestion from someone else. Yes.
Like unfamiliar feature for the user.
Okay. Yeah. So a feature that the user finds confusing.
Or like uncomfortable for the user.
They're uncomfortable. So it's a usability issue. They find it difficult to use that feature. It may be confusing. It may be difficult for them to read. It may be that they misinterpret things easily. It may be that it's really painful because each time they have to go through and click 10 things just to insert one more, go back and delete something just to and add it back in just to change one thing. So it's a usability issue. It's something impairing the user experience, even though it's working properly. It's working properly in the sense that it collects the requisite information. It's correct from a computational standpoint, but it's a pain for the users. Have you ever had pain like that in a software program? Yes, with Moodle. Yeah, you're not alone. Not alone, buddy. Okay, so, I cannot send an attachment to you in emails to the class. There's no way to add an attachment to an email to the class. I could send announcements, like I could send messages out to the class, but there's nothing to add. I can put in a link, but then I gotta upload it to a separate place. Kind of for birds. Usability issues, okay? Design departures from requirements is another thing. This is not a bug, but it's a case where we may have built the program right, but we haven't built the right program. It's not a bug per se. It's not a logical mistake, but it's a defect. In addition to just finding any bug, we're often seeking and testing to find important bugs. Bugs that are either happen a lot or they're really serious when they happen. In short, things that are high priority is often what we're focused on. And it gives immediate feedback on rough quality. I mean, testing, even if you don't end up creating a defect report, you can often give information to developers. Something's wrong here. It's behaving erratically. It's behaving weird. And I haven't been able to pin it down to a bug report or to a particular context, but sometimes it's really slow or something like that. So performance issue. You can give feedback on rough quality. Can also help identify usability issues. It's the testers often who are going to have that user perspective on things. And it can help, and this is critical, it relates to one of the most important principles that comes out of this class. Testing can help you identify process problems that have contributed to or defer identification of bugs. It can help get you to the point where you can discover in ways to improve your processes within your project. So how do we make ourselves less vulnerable to a bug coming about? Do we need to educate people better? Do we need to have people shadow each other more commonly, for example? Do we need to give people a tutorial in use of mobile programming by someone who's an expert like Dylan? Are these things that would have prevented this bug from coming about? If so, maybe we need to do them. It lets you reflect on what we need to do process-wise and as a group in terms of our broader actions. It's not merely about finding the bug or fixing that particular bug. It can also help you improve improve your testing process by asking, why didn't we find this bug earlier? Why didn't we find it in a peer review? What is it about our peer review that made us miss this bug? What can we do to improve those peer reviews in the future? Okay. So the principle of testability that I make here is that it can often be difficult if you're not planning ahead of time to test your program carefully. It can be difficult to determine the cause for errors. Okay? It can be difficult to test it effectively. When you're building your program, when you're designing the interfaces, the methods in place, for example, trying to figure out what goes in what method, you should be thinking about what type of design would help make this more testable. What sort of division between methods would let me test this algorithm more effectively? And a classic example is you put an entire algorithm, a complex algorithm, say to route buses from one location in Saskatoon to another. You put it all in one function, all in one method, say in a class. There's a lot going on there. It's hundreds of lines. It's hard to read, but what I want to concentrate on here is the fact that it's hard to test. It's much easier to test if you divide it into many methods, and you have one method call another, or if you have one class call another. Why is that easier to test if you divide it up into several different methods or several different functions? Why is that much easier to test? Why is it much easier to get to confidence that this algorithm is working properly? Yes?
There are just more gates of which you can check.
That's right.
The progress of the code.
Good. Good. So you could set a debugger to sort of to report values at a certain point, and you have sort of more checkpoints that you can explicitly access easily, right? That's true. Why else could it help? This is a very important point, folks. Why else could it help? Anyone else want to contribute before I get to Josh? Why else? Yes. Yes, that's exactly it. So look, you can start by testing the smaller functions that are called, smaller methods. And then you work up to the larger algorithm, or larger pieces of that algorithm. So you start by testing individually with unit tests, the sub-pieces, before you go and you test the entire thing. Because there's a lot going on internally if it's all in one method. And you can't directly see what those things are, short of getting it to print things out or stepping in a debugger. And that doesn't make for good automated testing. Do you understand that? If you want to test this code in an automated fashion, you want to be able to see what's going on at different points, right? And the best way to do that is to have it call off to different methods and to be able to test those methods, make sure they're working properly, and then to be able to work up to larger subsets of the overall code and larger subsets yet, etc. So you're testing each of the sub-pieces, developing confidence in them. You're not just trying to bang against the whole thing, beating your head against the wall of this big algorithm without being able to see what's going on internally in an automated fashion. You want to be able to have automated tests, ladies and gentlemen, with respect to those sub-pieces, and then work up to successively larger pieces, and then the whole. Does that make sense? Okay. There's other reasons too, though. Can anyone come up with a further reason? What is it about these boundaries between these functions that confers extra value, particularly in a modern software engineering process, but even, ladies and gentlemen, when I wore a young man's shoes? What is it we can do at module boundaries or function boundaries that allows us to actually simplify the testing process so we can test one thing in isolation from the others? we can create, and I will put up on the board 3 different related terms for it. These are all highly required, and there's a high degree of confidence that one of them will appear on the final exam at least. And I'll put them in sort of chronological order. We can think about stubs. We could think about fakes. And we can think about mocks. Do these terms mean anything to anyone? When we say I've stubbed out, one of my first professional programming jobs was working on the Excel team. And I needed to work on some code, and some of it was stubbed out initially. What does that mean? That code was stubbed out. They said, oh yeah, there's a function. You'll be working on this function, but right now it's a stubbed out version of that. Yeah.
That usually just means they have kind of the like basic body of the function, but it doesn't actually do anything.
Right. It doesn't do the full job. It's a particularly simplified version of it. It's a version that's there as a placeholder, a stand-in. So we could talk about it as a placeholder or a stand-in until the full routine is written. But why would we need a stub? I mean, why go through the work of creating the stand-in or placeholder? Yes.
So that you can know what the accepted outputs are and know what the
That's right. And so that's good. We want to think some about the expected inputs and outputs. But what can it do that's very useful for us if we have that stand-in? Lets you write good. Lets you write testing code. And the testing code could be testing code against that, then expand the stub into a full routine, for example, as you show, oh, this test failed, so I'll expand it some more, test failed, expand it some more. But often what it lets you test is something else that depends on this. There may be another piece of your program that calls off, so maybe you stub out foo, in part because bar is going to call off to foo. And you want to test bar. You want to focus on testing bar in a unit test sort of way. How are you going to unit test bar if it depends on foo? Now, I mean, to test bar, don't you have to test them together? No, you want to try to avoid that, actually. You want to cut through complexity. You want to simplify your problems. You want to divide and conquer. We have all these different names for it. But fundamentally, we want to be able to test smaller bits of functionality first before going on testing the full thing. If we just launch ourselves against testing the whole system, often there's a lot of things awry, and it'll take us a lot longer to get to the root of the problems. We'll find those problems much quicker, ladies and gentlemen, if we start testing individual pieces. So if bar is a function called foo, we can test bar by stubbing out foo first. So it actually doesn't call the true foo. It calls a version of foo that it has extremely simple functionality. It returns a fixed value, for example. Right? And then we see if bar works with that. Right? We want to focus our attention on bar. Well, if foo returns some fixed thing, we know what it is, we know what bar's behavior should be, right? Because we know foo is returning something fixed. And so we can really exercise bar. And then we may go put foo into place, or the full foo. So we'll often do this stubbing out, partly to get our system up and running, just because we need a placeholder, but partly for testing. We want to be able to test it. But ladies and gentlemen, the theory on stubbing as a general process has come a long way since when I was a young man. And now we speak more about fakes and fakes and particularly mock stub. And mocking is a best practice that I want you folks to put into place. Nay, more than that, I expect you folks to put in place. Mocking takes this general idea of having a doppelganger, a substitute for a piece of your program, but it allows you to do it in a flexible way, so you can do it any time. You don't have to go and actually remove the function and put a substitute in. You can just tell it, hey, mock this out for now. Mock this whole class out for now for me. When I say create an element of class, keyboard, actually create the mock instead. And the mock does more than just returns fixed value. The mock, ladies and gentlemen, further tests that it's getting meaningful arguments. So you can test, well look, if bar calls foo, is it giving it meaningful things? For example, maybe it's providing it occasionally it's providing it with a null pointer, right? And maybe that's not supposed to. And by putting some test code in foo automatically through mocking, you can have it spot these cases where it's getting illegal values passed to it and flag them to the tester. Could that be useful? Yes. So now, in a way, it's an expansion of what Josh said earlier. You have more gateways. You have more places where you can check what's going on at different places. And ladies and gentlemen, we can do that by hand. And that's great. Dividing into modules by hand, we could put in a little test there, put in an assertion there at the beginning of foo that it's been given something that's non-null as a parameter. Make sure it's not null, and it would flag it if it weren't. But mocking allows you to do this automatically, almost automagically. You can tell your mocking system, hey, mock this class out for now. You don't have to go modify the code base. You can just say, mock this out for now, and run these tests. And now we're doing it not against the true version of the keyboard class or the sorting class or the message class. Instead, we're doing it against the mocked version of it. And using mocking in this way can be really helpful for testing. It can be helpful for debugging as well. You want to set things up in a very specific, repeatable way so that when you test, when you're debugging this part of the system, you're debugging just that part. You don't have to worry about the other parts. You can use mocks of those other pieces. Okay, so here with mocking, we have the ability to sort of temporarily stub out, as it were, pieces of the program in a very flexible fashion, in an interactive fashion, and put them back in when we're done. Okay, so that's one thing, another benefit, ladies and gentlemen, that comes about by having interfaces. But Josh put it well in many ways. That because there are more gateways, you have more opportunities to see what's going on, more opportunities to check things, more opportunities to test sub-pieces of functionality before just flailing against testing the whole thing, the whole hairball. There's other ways to promote testability too, and one of them goes right along with this, specifications. You can write out a description of what these small functions do that are called within this larger algorithm, that each of them takes values only of a certain sort, they return values of a certain sort. You can test those specifications using things like assertions. And specifications help us to write test cases. They help us to guide what test cases definitely need to be written. Testing is promoted by modularity, by breaking things into pieces. It's hard to test something that's opaque, that's one big thing, you can't look inside it easily. It's easy to test things that are implemented across many different functions. Another thing that promotes testability is writing tests first. Another is logging and profiling, and I'm going to get to that. Good documentation. I spoke about mocking frameworks. And I'm going to briefly mention hooks here. So The idea with the test hook, folks, is this. I told you that professional software developers, when they want to test their program against a variety of errors, disk full conditions, for example, out of memory conditions, as another example, but even things like disk corruption, they don't necessarily have to go corrupt their disk to do it. If they want to test it against a network card error, they don't have to go spray salt water on their network card. They don't have to go take a sledgehammer to their disk to cause it to behave erratically so that they can test how their program behaves. You don't have to do those things. Basically, what do? You simulate it as if there's throwing those errors, and you see if your program handles it properly. It's a common technique. Now, there's ways to do that. There's actually programs out there. Canned Heat, for example, is one that was early on in the Windows front that will artificially create programs like shortages of memory, shortages of disk space. It'll make it seem as if the disk is full. But a lot of the art here is putting hooks into your program that will create things, create errors as if errors have happened, but otherwise do things that will be useful for enhancing your insight to what's going on. An example would be having a bit of code that enables or disables logging from a particular section of code. So that you can tell this code, hey, log everything that's going on, log only these important things, or don't log any information. That's useful. Could you see how that would be useful for testing, ladies and gentlemen? The ability to log what's happening. Furthermore, it can be useful for debugging. You're trying to understand what's going on, why is this thing crashing, and you look at a log of it. Could you understand that? People comfortable with that? Logging, printing out what's happening, can be very valuable. So, for example, saying, okay, this function is connecting to the database at this time. It's connecting to this machine. And here's a further log that it's successfully connected to the database, to this database server, and this particular database on there. Now it's reporting that it's attempting to retrieve customer information for a certain customer. Having a printout about what's going on within your code here can be quite useful for validating what's going on in the program, that it's operating correctly, and quite useful for debugging particularly. So having some hooks to enable logging, for example, of pieces is useful. Another thing is sometimes you have complex data structures that your code uses. There's an array that it uses, or there's a hash table, or there's a display tree, or there's a heap that it uses, or a stack. Sometimes it's really useful to have the ability to print out information on that data structure. Print out everything that's in that data structure. Is that code going to be used by the user? No. The user doesn't want to see a description of your hash table. They couldn't care less about your hash table. They want to get their job done. As long as it does its job, they don't care whether it's a hash table or a heap or a stack or who knows what. They don't care about that. And this is what I mean by a hook. It's code put in there for the purposes of testing or debugging, enhancing testability, to print out these, for example, these data structures. Another example of a hook would be something to trigger rare conditions. Custom command languages. Some programs have a debugging interface where you can actually type commands. Report locks taken out on a database. Report sort of what's happened thus far. How many locks are there on the database? Finding a connection state for some connection to the server. This program's crashing. Is it because this connection has been lost? Let me go have it report the connection state all throughout the program, and we'll see if it reports a lost connection. To examine a state of a cache. Maybe it's maintaining a cache internally so it can get values quickly that have been recently computed. It's an extremely useful technique, memoization and caching, to improve program performance. A cache is normally hidden from the user, almost by definition. It's a secret data structure that's kept internally, and as far as they're concerned, they just get their answers. But sometimes you do it by grabbing things from the cache, other times you do it by fully computing the answer. You've seen that before? Have you seen caching? Or have you heard about caching? Okay, well, sometimes it may be useful to report the contents of your cache because you're getting weird behavior, the performance is really lagging. That would be an example of a test hook. Does that make sense? Again, it's code that isn't expected to be used as part of the production system. It's not going to be used by the user directly, but it's useful for debugging and testing. Clear? Okay. Simply report back contents of database tables. Basically, print out useful information that gives insight as to what's really going on within the program. Later, we'll see if we can get into the issue of saying implementation from interface and where test hooks get into that. So I want to flag for you logging, and this is probably going to be the last subject we're going to deal with today. Logging is the process of recording a trace, a record, a trace of events during program execution. I made reference to it there and showed an example. For example, test hooks that enable logging are very valuable. But the key thing, folks, is here, it goes beyond just doing printf statements or doing printlns, even to standard input and standard output. One of the key ideas is to make it flexible so you can enable it or disable it at runtime. You don't have to recompile the whole program. Insert statements and recompile and run it. You want to be able to disable and enable it at runtime. So if something's going wrong, you can turn it on at a moment's notice and see what's going on. And secondly, you do it at multiple levels. So you can say, show me more detailed information or show me less detailed information. And I want to highlight log4j as one format that makes this extremely interesting, extremely easy to do. The idea here is you have config files, which can be updated at runtime without updating the program to specify logging characteristics. You can then log things with different levels of priority, and a given log can go to multiple places. It can be used to send a mail, it can be used to write things to files, it can be used to upload to a server, etc. And you can put in calls to these sort of methods to do that logging. This is an example of logging. This is something of higher priority, this is something of lower priority, and this is an example of configuration file where it tells it, for example, what sort of information, what's the format by which it can be output, and or by which it's rendered, and the sort of information that it's, the sort of level of priority that it's currently going to report. And one of the important issues here is that you can enable it just for pieces of your program, just for certain sub-areas of your program, and you can get it to put it in many places. For example, to stood out here to a file, and the same logging session could be logged to multiple of these locations. Okay, I'm going to comment on today with this. I want to just mention in closing that you might think about error messages that are automatically sent